Very good, Tharif. Go for the next question. Savage, we just started from here. Today we are going to cover this ECS electrochemical series, questions on electrochemical series, and also delta G naught. We are going to talk about gives free energy, and also uh, Faraday's law of electrolysis. So the first question, this is based upon ECS, that is electrochemical series, and second is based upon delta G naught formula. Any answer, Savage, for question number 36? Very good, Tharif. Shavez, any answer for question number 36? Yes or no? Faiza, are you able to see the screen? Okay. So please do solve it. Savez, very good. You have got the right answer for question number 36. Go for question number 41. Faiza, let me know if you are not able to solve question number 36. The value of electrode potential is given. You need to write this in decreasing order of reducing power. Very good. Go for the next question, all of you, and please go for question number 41. For the reduction of silver ions with copper metal, the standard cell potential was found to be plus 0.4 volt. inert cell is given at 23 energy? Very easy question. Based on one formula directly, and you can solve it. Let me know if you're not able to solve this. Chavez and Faiza. Chavez, any answer? See, I'm gonna give you the formula. The formula for this is very easy. Delta G naught is equal to minus NF E naught cell. Now you know N is number of electron transferred, so you know that copper metal is basically in Cu plus 2. In Cu plus 2. So always remember that this copper is displacing silver. So Cu plus Ag plus will give you Cu plus 2 plus Ag. To balance it, what you need to do, it's very simple. Copper is converting itself from 0 to plus 2. So there will be 2 and there will be 2 to balance it. Very easy. Now number of electron you can see that is 2, and Faraday's constant that you know 96,500 coulomb, and inert cell is also given as 0.46. So if you are going to multiply it, you're approximately you will get 89,000 joule and convert it into kilo since there is options in kilojoule. So it will be the answer simply will be A. Is that clear, Faiza and Chavez? Very good. Now moving to the next question.
Sir, can you scroll up?
Okay. For this question,
Yes, yes.
please do write it. Let me know.
It's finished.
Okay. Moving to the next question. You need to calculate the value of equilibrium constant. So you can easily solve it. Basically, from Nernst equation, there is a relation between E naught cell and K. And from there, you can easily solve it. If you have revised it, it's easy. And if you're not able to solve it, just let me know. Let me know if you're not able to remember this formula, and if you don't remember the formula. Tharif, Faiza, and Shawiz. Yes. So see, if you remember this formula, E cell is equal to E naught cell minus 0.059 upon N log product upon reactant. Can anyone tell me what is the name of this equation? Any one of you? What
P by R is
is the
equilibrium
name?
constant.
What is the name of this equation? What is the name of this formula?
Nernst equation.
Nernst equation. Nernst equation. Very good. So whenever we are going to, very good, all of you. Whenever you can see in the question, it has been said equilibrium constant. That means the process or the reaction is at equilibrium. So at equilibrium, delta G equals to 0. That is understood, right? If delta G is positive, then the process is non-spontaneous. If delta G is negative, then the process is spontaneous. And if delta G equals to 0, that means the process is at equilibrium. And you know that delta G is equal to minus NFE cell. So if any process is at equilibrium, that means this quantity is zero, and this quantity will become zero if on the right hand side it will be zero, then left hand side it will be zero. So number of electron cannot be zero. Faraday's constant is, it's also cannot be zero because it has value 96,500. And in any reaction, if there will be loss or gain of electron, the number cannot be zero. So what should be zero? This E cell will be zero, and hence you can see at equilibrium, I'm deriving the formula basically, so don't forget it if you remember only the Nernst equation. At equilibrium, E cell equals to 0. So if this part becomes 0, I'm just going to move this to the left hand side, and it becomes E naught cell is equal to 0.059 upon N log of, and since it is at equilibrium, this product upon reactant can be written as log Kc. Everyone got it? This is the formula that we need to apply. So if you know the concept and if you remember only the Nernst equation, you can easily apply this concept and get a new formula to get your answer. So as you can see now, what you need to do, the equilibrium constant, we need to calculate this Kc. So accordingly, we are going to apply the, we are going to put the value according to the given value. So E naught has a value 0.46, and here you can see 0.059. N is the number of electrons. So you can see it is moving from 0 to +2, or you can take from here to here. Any one of them you can take. So number of electron N, and here it will be log Kc. Again, if you are going to solve it, since this quantity is in multiply, so log Kc will be equal to, you can see if this is in division, so this will be, if this will come in multiplication, and this is in multiplication, so this will come in division. And accordingly, you are going to solve it and you will get your answer. Let me know what is the answer after solving it. Basically, if you are going to multiply it, you will get 2 6 are 12, 2 4 are 8, 9, and 200, 0.059. And if you are going to divide it, you will be getting 15.57. This is the value of log Kc, which will be equal to 15.57. And then you are going to take anti-log. Anti-log of 15.57, that will be equal to Kc, and hence since anti-log, this if you are going to take anti-log, then this log will be cancelled and there will be anti-log 15.57. And if you are going to take anti-log of this, the value will be given, then you will be get approximately 3.7 into 10 raised to the power 15, whatever is this number, or you can write 4 into 10 raised to the power 15. So accordingly, the answer will be C. So basically, in the last, there is concept of antilog, and rest of it is very, very easy. Let me know when you are done with this, everyone. Are you done with this, Tharif, Shawez, and Faiza?
Yes, sir.
Okay.
Yes, sir.
Moving to the next question, which is very, very easy. It's basically the representation of cell is given, and you need to write the reaction. So please do solve it. Very easy question. Okay, very good, Tharif. Faiza, any answer? Very good, both of you. Moving to the next question. This is basically directly, it's a formula. Let's see whether you know it or not. Very easy it is also. Shravij, were you able to solve the last question?
Sir, I was actually disconnected.
Okay. Actually, this question was, I was talking about this question. From this representation, you are going to write a reaction. From this representation, you are going to write a reaction. Will you be able to write a reaction for this representation? So I'm going to explain. You can see A is moving from A to plus A plus, and B plus is moving from B plus to B. Now what you need to do, just add them. A plus B plus will give you A plus plus B. And hence the answer will be C. Isn't it easy?
Yes, sir.
Okay. Moving to the next question, which is also very easy. Basically, it is just a formula in which you have to remember this Gibbs free energy with equilibrium constant, that is ln k. So this is the formula, and hence not it will be delta G naught. Okay, Tarif. So the answer will be A. Got it? Yes or no? I'm gonna just derive this formula for you. Please do write it. You know what? I already gave you this formula. Basically, you know that this equation is, everyone knows that this equation 0.059 upon n ln q is reaction quotient at any time. Product upon reactant you can also write. And if this product and reactant will be equal to q is reaction quotient other than equilibrium. This is equilibrium, not equilibrium constant. Basically, it is other than equilibrium. Now, at equilibrium, what will happen? Everyone knows that at equilibrium, I just told you that this part will be zero. So if this part will be zero, so we can write E naught cell will be equal to, now see, this is your 0.059. But before this, what we had actually, we had 2.3, not 2.303, since I'm keeping it in ln. So what I need to write is very simple. I can write directly RT upon NF and F ln K. Can I write this? Yes or no? At the place of this, I am also going to replace here as well. I can write RT upon NF ln Q. Can I write this? Yes or no? When you derived the Nernst equation, it has started from here. Now you can see E naught cell RT upon NF ln K. Now we know that delta G naught is equal to minus NF E naught cell. Now, the value of E naught cell from this equation can be written as delta G naught upon NF, and it will be negative. Yes or no? Please do respond. From this, we can get this, and E naught cell at the place of, I'm going to replace this, and we will get delta G naught upon NF will be equal to RT upon NF ln K. Can I write this, everyone?
Yes, sir.
Now you can easily see that this NF and this NF both will be cancelled. And also I forgot to write this point. Delta G naught NF, there is negative. So this NF and this NF can be cancelled, and hence minus delta G naught will be equal to RT ln K, and hence delta G naught can be written as minus RT ln K, and hence the our answer will be, our answer will be A. Please do write it. Very important. Let me know when you are done with this.
So these are JEE questions.
No, it's not JEE questions. You will get JEE questions after this. Everyone done with this?
Yes.
Hmm. Yeah. Please do this. After this question, you will get JEE questions from here. Please let me know the answer of last question 59. Very easy question. It's wrong. Sorry if it's wrong. Very good, Faiza. Arif, look at your answer. Which one of the following is the strongest oxidizing agent? Very good, Shavez. Arif, do you need any explanation or you have corrected it? Very good. No. Very easy questions. 2019 main April 1st shift. Please do this. I think it's wrong. Please. Pfizer. Okay. Pfizer, it's correct. If it's wrong, please review your answer. You need to oxidizing power. You know what? E naught R value increases. Basically, E naught R directly proportional to oxidizing power and inversely proportional to reducing power. So the one with highest value of E naught R will have the greatest oxidizing power. So you can see the highest value I'm looking at CO plus 3. This will have the most oxidizing power. So this will be the maximum. In two options, this is same. So you are going to leave these two options as incorrect. Now, after this, the small value is this. After this, it should be PB plus 4. So it comes here, not here. So the answer is B. Very good. Very good, Shavez. Tharif, have you got it?
Yes, sir.
Very good. Now moving to the next. Very good, Tharif. Very good, Faiza. What about you, Shawiz? Any answer? Very good. Now moving to the next. Very good, Tharif and Faiza. These questions are very easy and important as well. You can see most of the question is repeated from this chapter. So ECS, Nernst equation, Corlot's law, these are some important topics. RD is not the correct answer. See, you need to reducing power. If the value of R E naught are inversely proportional to reducing power, which one will have the maximum reducing power? Very good. Now it's correct.
Dvayamsha sir, S and D.
Yeah, now it's correct. Very good, sorry. Uh, no, Faiza, it's wrong. Please be careful regarding this type of question. And Faiza, let me know if you A is also not correct answer. See, you need to tell me the strongest reducing agent. E naught are inversely proportional to reducing power or reducing agent. So first you are going to decide the one which is having the less value so that it will have the most reducing power. So you can see CR plus 3. So now just wait a minute. It's very important, Faiza. So if you are going to take CR plus 3 or CR, there is two options, both are present here. Now you are going to look at this reducing agent. What does reducing agent means? The one which oxidize, the one which oxidize, right? Yes or no? So you can see, just wait a minute. Just wait a minute. Okay, the one which get oxidized. Now, can you tell me CR or CR plus 3, which one will get oxidized? Oxidized, that means loss of electron. That means loss of electron. So loss of electron will happen from Cr to Cr plus 3. That's why the answer is A. That's why the answer is A. And in the second option that you had given, what is it? Faiza, that was correct. So option A is correct. If you haven't got it, just let me know. I will again explain this. Since you know that E not, can you repeat again?
So the answer is not B.
Yeah, the answer is A, not B.
Can you explain why?
Yeah, I'm going to again explain this. Now you can see E naught R is inversely proportional to reducing power. Everyone knows that, or reducing agent. This is the criteria. Harif, Faiza, and Savage. Everyone is aware of this. E naught R is directly proportional to oxidizing power and inversely proportional to reducing power. Since we are going to only talk about this reducing power, so you can see, you can easily extract that this will have the most reducing power. Yes or no? Please do respond.
Sir, but it is having less potential.
Yes, exactly. As I told you, E naught R is inversely proportional to reducing power. So the one which has the lowest value of E naught R will have the greatest reducing power. Yes or no? Chavez.
Yes, yes, yes.
Now, what you need to do? This will be your answer. But here, Cr plus 3 and Cr both are present in the option. Now, look at the question. Strongest reducing agent. Strongest reducing agent. What is reducing agent? So you know that the one which get oxidized, or the one which is the one which has oxidation, which is known as reducing agent, and the one which get reduced is called oxidizing agent, right? So the reducing agent is the one which get oxidized. Yes or no? Tell me. Oxidized, that means oxidation taking place. So there is Cr and Cr plus 3, and there is Cr plus 3 and Cr. Can you tell me in which one of them is getting oxidized or oxidation taking place? You can see chromium going from 0 to plus 3. That is your oxidation, right? And this is your reduction. But what we needed oxidize, the one which get oxidized. So which one is getting oxidized? Chromium, and hence A is the correct answer. Is that clear, Chavez, Tharif, Faiza? Faiza, good.
Yes, sir.
Yes, sir, yeah.
Okay. Now moving to the next question.
So can I scroll up?
Yes, yes, why not? Moving to the
Sir, can
next
you
type of
scroll down?
scroll down. Scroll down or up?
Down.
Down is nothing. Now, what I was telling you is that we're going to solve this question. Very important question. It might be asked this time in your G. Oh, sorry. Just wait a minute. Okay, are you done with this, Chavez, Farza, and Farif?
Yes, sir.
Okay. Moving to the next question, which is very, very easy. Please do it. It's a question from Exemplar. Let me know if you're able to solve this, yes or no. Take your time. Very good, Tharif. Any answer? Chavez and Faiza. Very good, Chavez. Faiza, have you got it or should I explain it? So the correct answer, everyone is good. Faiza, okay, I'm going to explain this. You can see this is the equation. Okay. And also the graph is in between this and this. So there is a relation between this is your y-axis and this is your x-axis. Basically, this is your x-axis, right? This is your x-axis. So you can see x and y are directly proportional to each other, and since y is equal to mx plus c. Now, that means a straight line, since they are directly proportional to each other. So a straight line. So this option is not correct, but there is a straight line graph 1, 2, 3. Now, which one is correct? Always remember that if y is directly proportional to x and there is negative sign, then downward graph will be there. And if y is directly proportional to x and there is positive sign, so upward graph is there. Now you can see two upward graph and one downward graph. How you are going to find out? Now what you need to do, it's very simple. You need to play with the equation. With the equation, I'm gonna show you. With the equation you are going to play. How you are going to play? It's very simple. Now I'm going to write the equation first here and then explain. Now, since it is given that E that means E mg plus 2 slash mg is equal to E naught mg plus 2 slash mg minus 0.059 upon 2 log of 1 upon mg plus 2. Now everyone knows that if it is 1 upon x, if it is going in numerator, what you are going to write? 1 minus x raised to the power minus 1. Yes or no, Faiza? So if you are going to write this as this, E naught minus 0.059 upon 2 log of, and there is mg plus 2 which will have raised to the power minus 1. Just wait a minute. Since you are moving mg plus 2 from denominator to numerator, so it will have raised to the power minus 1. Are you getting my point, Faiza? Now, what you need to do, you know that log a raised to the power n, then this power will come and multiply here, n log a it becomes. Accordingly, this negative will come here and multiply here. So minus 1 and minus is already there. So E will be equal to E naught plus minus minus plus 0.059 upon 2 log of mg plus 2 it becomes. Now you can see this is your y-axis and this is your x-axis, which has positive sign that ensures you that the graph will be upward. Now, it origin from origin or above origin? So you know that y is equal to mx plus c. If c is there, which is in positive, then it is above origin. And if c is 0, like y is equal to mx, then it will start from origin. And if it will be y is equal to mx minus c, so it is below origin. Got it? So the answer is 2. Very easy and very important question it is. Now I'm going to give you a question on electrolysis. Let me know when you are done with this, Faiza. Very good.
Sir, if the graph is y is equal to mx plus c, so it will start from above origin.
Yes, that depends upon intercept.
Okay.
Plus c, that means the intercept c is positive, that means above origin. C is 0, that means from origin, and if c is negative, then it will be like this. Okay.
Yes, sir.
Okay. Of just wait a minute. This question based upon electrolysis, which is very, very easy. You can easily do. On electrolysis of dilute sulfuric acid using platinum electrode, the product obtained at anode. Okay, very good. Chavez. C is the wrong answer. A is also wrong answer. I'm going to explain. You can see dilute sulfuric acid. Water is also present there in high level, and H2SO4 is also there. So both will give H plus, and here it will be OH minus, and here it will be H plus, and here it will be OH minus. Sorry, SO4 minus 2. SO4 minus 2. B is also wrong answer. It cannot be H2S or H2O, SO2. Either it will be oxygen or either it will be hydrogen gas. Now you know that at anode, what will happen? At anode, oxidation takes place. And since it is dilute sulfuric acid, so basically water will oxidize. Water will oxidize? H2O will convert itself into O2 plus 4H plus 4 electron. 4H plus 4 electron. Okay, got it. Chavez, your answer is wrong. Just wait a minute. Let me explain this.
Here, no option is correct.
Yeah.
Here, one, no, which any option is not correct.
No. The option A is correct, basically. Option A is correct. Now I'm going to show you how. You know what will happen if you have studied this. You know that this is your H plus and H plus OH minus SO4 minus 2. So at cathode, everyone knows that H plus will go and gain some electron and convert itself into H2 gas. Yes or no?
Yes, sir.
If Chavez, at cathode, this will be the product hydrogen gas, right? Faiza, Tharif, what is the product at cathode? At cathode, hydrogen gas will form. Yes or no? Harif and Chavez, why are you not responding?
Yes, sir. Yes.
Okay. When you are going to add anode, so you know that at anode is positive and this is your negative. So at negative electrode, positive ions will go, that means cation. And at positive electrode, negative ions will go. And you have two negative ions, OH minus and SO4 minus 2. So which one will go? OH minus will migrate first and it convert itself into H2O plus O2 plus, here it will be 4 electron it will release. So the your at anode, it will be oxygen gas. This is the same reaction which is given in NCERT. If you will look it here. Got it, Tharif, Chavez.
Yes, sir.
Okay, please let me know when you are done with this. Moving to the next question. Please do write that equation, very important question that is.
Answer is A.
Can you repeat again?
Sir, is the answer A?
Yeah, answer A. Answer is A, not D. Got it. Can I move to the next question? Can I move to the next question? Okay, Chavez and Tharif,
Yes, sir.
please go for this question. So, early, have you solved this question before? Tharif?
No, sir.
Yeah, fast. Yes,
Okay, so please do solve it again and then send the answer, not by, if you
sir.
remember the answer, that is good, but you should solve it if you have solved it. Just let me know, Chavez and Faiza, when you are done with this. Yes, Cl2 gas will go away, but that does not concern you. You should focus on calcium. Okay, I'm gonna explain this. You can see
Yes, sir.
number of Faradays. You need to calculate the number of Faradays required to produce 20 gram of calcium from molten CaCl2. If you have CaCl2 in molten state, that means calcium will be in +2 oxidation state. Since it is positive, it will gain electron and convert itself into calcium. Now, how you read it? This is basically 2 mole electron that is giving you 1 mole calcium. Can I write this? Yes or no?
Yes, sir.
2 mole electron. You know that 1 mole electron is equal to 1 Faraday. So 2 mole electron can be written as 2 Faraday, and that is giving you 1 mole calcium that will be equal to its atomic weight. Yes or no? 1 mole will be equal to its molar mass. 1 mole is equal to its molar mass. So I'm just gonna write it in opposite like this. 40 gram calcium is given by 2 Faraday. So 1 gram calcium will be given by 2F by 40 Farad Coulomb. So in how many grams we need to calculate? 20 gram. So it will be 2F upon 40 into 20. You just need to see, you can see 1 Faraday it is. So the answer, to get 20 gram deposition of calcium, you will in need of only 1 Faraday. Got it, all of you?
Yes, sir. Got it.
Very good, very good. Please do write it and let me know when you are done with this. Done with this calcium. Now go for this question. Any answer for this question number 20? Very good. Sorry. What about you? Peasant, savage? Let me know if you're not able to solve this. Are you able to solve this, Chavez and Faiza? Yes or no? Okay, Faiza, very good. Now I'm going to show you how you are going to solve it. It's very simple. You can read it from, it is going from MnO4 minus to MnO4 minus. So this is your MnO4 minus 2 and it converts into MnO4 minus. Now what you need to do, can you calculate the oxidation state of manganese on the left hand side and on the right hand side? Chavez and Faiza, what is the oxidation state of manganese here on the left hand side? Will you be able to solve it? So if you're going to solve it, it is equal to plus 6, no, plus 6. And if you're going to solve it, it will be equal to plus 7. That means basically it lost 1 electron. Yes or no? MnO4 minus 2 to MnO4 minus. You can write like this. That plus 6 to plus 7. You are getting just from this 1 mole and you are getting 1 mole electron. That means 1 Faraday. So from 1 mole you are getting 1 Faraday. So from 0.1 mole MnO4 minus 2, you will get 0.1 Faraday. Yes or no? I just balanced it. Plus 6 to plus 7. Plus 7, that means it lost one of its electron. It loses electron. So 1 mole is giving 1 mole electron. That means 1 Faraday to 0.1 mole of MnO4 minus 2 will give 0.1 Faraday. And you know that 1 Faraday is equal to 96,500 Coulomb. So it will be equal to 96,500, not 00101. And hence the answer will be equal to 9650 Coulomb. Is that clear, all of you?
Yes, sir.
So the answer will be C. Very good, and thank you. Can we move to the next question? Okay. So these are some questions based upon electrolysis, mainly Faraday's first law. So let me know when you are done with this so that I'm going to give you another question, which is also very, very easy. Okay. Savage, are you done with this?
Yes, sir.
Okay. Moving to the next question, which is this. Please do it. Any answer? Very good. What about you, Staviz? Very easy question it is. Any answer, Staviz, for this? I'm going to explain this. How many grams of cobalt will be deposited when a solution of cobalt 2 chloride is electrolyzed with a current of 10 amperes? Time is also given. Atomic mass is also given. Now, if you have studied mass is equal to mass deposited is equal to electrovalence equivalent into Z into Q. And Z can be written as E upon F and Q can be written as I into T. So E is equivalent weight and equivalent weight can be written as atomic mass upon N factor. F will be as it is I into T. What is the atomic mass? 59. And N factor is basically charge on metal. So cobalt 2, that means 2 is the charge. Faraday's has value 96,500. Current has value 10. And time is 109 minutes. You are going to convert this into second. So if you are going to calculate it, you will be getting 20 gram. Is that clear, Shawiz?
Yes, sir.
So very easy. Basically, this is the first law of Faraday's. Please do write it and let me know. Can I change the slide? Yes or no?
Sir.
Okay. Now, this question that I'm going to give you is very easy if you will read it carefully and write the equation. I'm going to explain the question. H2 gas, just wait a minute. H2 is in gaseous state converted into H plus, and M plus 4, there is a metal which is in plus 4 oxidation state, converted itself into plus 2. Now, E cell, this question is purely based upon Nernst equation. Nernst equation. You are going to use this representation to write a Nernst equation. E cell is given as 0.092 volt when M plus 2 upon M plus 4 is also given is equal to 10 raised to the power x. You need to calculate the value of x. Think about it, please do it, and let me know if you're not able to do it. Yes, I'm gonna explain it very easy. So according to this representation, you are going to write an equation. So firstly, I'm gonna write it in two parts, oxidation or reduction. So first you can see H2 is converting itself into H plus. So to balance it, I'm gonna write it 2H plus and it loses 2 electron. Yes or no? Just reply me. Okay. And this is converting itself into M plus 2. So it gained 2 electron. So net cell reaction can be written as H2, which is in gaseous state. And here we can write M plus 4 in aqueous state, which is giving you now 2H plus. It is in aqueous state, and M plus 2, which is also in aqueous state. And now you can see this 2 electron and 2 electron can be cancelled. Yes or no? All of you, Faiza,
Yes.
Harif, okay. Now you are going to write, if you are going to write the value of K is equilibrium constant. What you are going to do, H plus. So whatever is the concentration of H plus, it will come in square and M plus 2 as it is, power 1 as its coefficient is 1 upon H2, which is in gaseous state. So its pressure will be taken into it is into M plus 4 as it is. Just wait a minute. M plus 4. Just wait a minute, please. Now it will not work. Okay. So here it is plus 4. Now I'm going to apply Lect. So you know that E cell is equal to E naught cell minus 0.059 upon what is the value of N? You can see what is the value of N. N can be written as 2. Because you can see it is going from 0 to 1 and there is 2 hydrogen, so total number of electron N is equal to 2. You can see watch it here and here as well. Now log of K can be written as what? You can see the concentration of H plus, the concentration of H plus is 1, so 1 is square, and here it will be M plus 2 as it is, and here it will be the pressure of hydrogen gas, it is also 1. So basically, and it will be M plus 4. What is the value that you will get of K? K will be equal to M plus 2. First of all, I'm going to write log K here, log K. And accordingly, I'm going to write this E naught cell minus 0.059 upon N log of, and here it will be M plus 2 upon M plus 4. Now, in the question, it is given that M plus 2 upon M plus 4 is equal to 10 raised to the power x, and E cell is equal to 0.0092. So I'm going to write E cell is equal to 0.092, which will be equal to E naught cell. E naught cell can be easily calculated. You can see the E naught of M plus 4 is given of 0.151, and E naught of hydrogen. Another quantity is hydrogen. That means a standard hydrogen potential, which is 0. So E naught cell can be written as it is 0.151. Yes or no? E naught cathode minus E naught anode, if you will do it, and E naught of hydrogen, the standard hydrogen potential, or ECS, is calculated with reference to the hydrogen, so its value is 0. So E naught cell will have 0.151 as it is. Now 0.059, and what is the value of N? That I already told you, 2. Here it will be 2, and log of, and you know that it is in the question, it is given that this quantity is 10 raised to the power x. Now what you need to do, this is x, so it will come here as it is, and 0.092 will be equal to 0.151 minus x into 0.059 divided by 2, and here it will be log 10, which has a value 1. Now you can easily calculate this. Basically 0.092 will be equal to 0.151, and this will be equal to minus 0.059 x upon 2. You can easily solve the value of x, right? Yes or no?
Yes, sir.
Please do it. Let me know when you are done with this. Everyone done with this? Yeah, D is the right answer. All of you, Faiza, Harif, very good. Very good. So this is it for today. In the next class, which chapter is going on in your school? Please do message with your name or with the chapter's name. All of you.
Sir, in school?
Yeah, in a school or in coaching as well. Right in Learnivio, which chapter is you have finished? Which chapter is going on? Alcohols in a school and alcohols in coaching. Okay. In a school, means not in a school. Let me know about the coaching only. Like Faza, Halolkin is going on, right? Halolkin and Halorins. What about you, Chavez? How
In
many
school,
chapters you have? No, no, not in school. Just tell me about the coaching. Everyone done with the chemical
yes, sir.
kinetics
Hello,
in
Alkan and hello,
coaching?
Arif.
Okay. Everyone done with the chemical kinetics? Yes or no?
Yes, sir. Yes, sir.
In coaching?
No, no, sir.
Uh, no, sir. Okay. So can anyone tell me which topic is going on in haloalkanes and haloarenes? Which topic is going on? Like preparation, chemical reaction.
Elimination reaction.
Okay. So let's talk about this now. Corrosion and batteries. You are going to study about this as well as revise whole electrochemicals, electrochemistry. Is that clear? In the next class, we are going to have some questions on this topic and this topic, and we are going to